We're going to go through the problems on the quadratics exam review problems. Number one, the graph of this function is shown for the domain -5 to 7. Um, the graph cuts the y-axis at 0, 4, so I labeled that right there. It's a y-axis intercept. Write down the value of q. Well, there's two ways you could do this. One is to remember from the investigation that ax squared plus bx plus c, the standard form. When you have the standard form, c is always the y-intercept, even if the parabola is off-center. So that's one way you could do it. You could say, yeah, the 4 is going to end up being the c value, or you could use algebra. So here we're going to go down here, write down the value of q. So they give you the form here, but without numbers in it. So we just copy it down here, 2x squared minus rx plus q. I just wrote that here, okay? And then what did I do? I said that, okay, they give us a point, which is 0, 4. X equals 0, y equals 4. So we just put these two numbers in to the quadratic equation that they gave us. So we put the x, we substitute x equals 0, and y we substitute 4. So that basically gives us 0 minus 0 plus q equals 4, which in the end is just q equals 4. Okay, so either way we found out that q is equal to 4. Then it says the axis of symmetry is x equals 2.5, which is something that we didn't know. Axis of symmetry is the mirror line that goes down the middle of the parabola. So this point here is actually 2.5, 0, right there. Find the value of r. Now, we had substituted in 0, 4 before. Now we go back to the original equation, which was 2x squared minus rx plus q, but now we know that q is 4, so now we can write 4, right? Find the value of r. Well, we know that there is the axis of symmetry going through the vertex, and it's x equals 2.5. So one of the things you can do is you can say, okay, well, x equals 2.5. Okay, it's also equal to negative b over 2a. Negative b is actually equal to positive r. So you could put positive r there and divide by 2a, and a is 2. So we have r over 4 equals 2.5. So we multiply 4 times both sides, and we get r equals 4 times 2.5, and that equals to 10. So now we have a value for r, which is 10. And so we keep the negative sign there, and then we put the 10 in for r, put the 4 in for q. So now we have an equation, a quadratic equation, and the only unknowns are x and y, which are fine. A quadratic equation has unknowns x and y. So now it says write down the minimum value of y. There's a couple ways you could do that. One is, you look here, the minimum value is going to be the vertex, which is on the axis of symmetry. So one of the things you could do is you could put in 2.5 in for x and just multiply it out. Okay, and that'll give you a number. The other thing you could do is you could use a calculator and plot it. So we're going to put in the formula, or the equation, 2x squared minus 10x plus 4. So 2x squared minus 10x plus 4. Graph it. Okay, did I put that in right? Let's just check it. Oops, I put in 0x. It should be 10x, right? So to insert a 1 there, I'm going to do second insert 1. Okay, now it's 10x plus 4. Now let's graph again. Yeah, so now it looks more like the graph that was up here, right? It looks pretty much like that graph. So now let's say we want to know the vertex. We can use the second calc function to find the vertex. Vertex we find using minimum if it opens up, and we use maximum if it opens down. So here we're just going to mark a point, any point to the left of the vertex, and just mark that one. Then we go to the right of the vertex, mark that one. And then it asks for a guess, and we could just guess anything in between those two. And it says that the answer is 2.49999, which is basically 2.5, and y equals negative 8.5. So we'll put when x equals 2.5, which it agrees with the value that we got for, or the value that they gave us up here, y equals negative 8.5. Okay, and we could have also gotten that by doing trace, and since we know that the axis symmetry is on 2.5, we could have typed 2.5 enter, and that would have also given us the y equals negative 8.5. Okay, so write down the range of y. Well, y ranges from this point down here, and we know that's negative 8.5 because we just found that. And then the upper limit would be like either here, oops, this point here, or this point here. Well, obviously this point is higher. Okay, so we need to figure out what is the y value when x equals negative 5. And we can do that with trace too. We could just go trace, and then we'll just type in negative 5. And it'll tell us that at x equals negative 5, y equals 104. Okay. So y ranges from 104, and the bottom value would be negative 8.5, because that's the vertex, and this is the value on the left when x equals negative 5. The other way you would do that is you could put in negative 5 in for here. You could go y equals 2 times negative 5 squared minus 10 times negative 5 plus 4, and that should also give you 104. Okay?